Hello there. I've had enough of algebraic fractions, so we need to go on to something else. So we're going to start by revisiting trigonometry, SOHCAHTOA type trigonometry. We had one of those in a test recently, but not all trigonometry is SOHCAHTOA trigonometry. Remember, SOHCAHTOA, or sin, cos, tan trigonometry, takes place in right-angled triangles. But what if you haven't got a right-angled triangle? What if the triangle that you're working with does not contain a right angle? There are two rules that you need to learn, which are to do with non-right angled triangles. One of them is called the sine rule, the other is called the cosine rule. And today I'm going to show you how the sine rule works to find missing sides in non-right angled triangles. First thing we're going to do, though, is look at how we label non-right angled triangles. Okay, so here we have a triangle that doesn't contain a right angle. So we can't really label the hypotenuse, although it might have a longest side, but there's no such thing as the hypotenuse. The hypotenuse has to be opposite a right angle. There is no right angle. So the way that we label the sides and the angles in a non-right angle triangle is as follows. We label the three angles with the capital letters A, B, and C. So I'm going to label this one as A. Doesn't matter which one's which. Sometimes it's done for you, sometimes it's not. So the angles, this is angle A, this is angle B, and this one here is angle C. The way that we then label the sides is as follows. If you find angle A, the side which is opposite angle A, so that's this one, and when I refer to the side, I mean the length of the side, this side here is side A. And to distinguish between side and angle, we use lowercase letters for the sides. So angle B is here, opposite angle B, that's this one here. You have side B, remember lowercase, and opposite angle C, that's this side here. Okay, we label that as lowercase c. Okay, so that's how we label the sides in a non-right angle triangle. So, the sine rule. Now, there are two versions of the sine rule. I'm only interested today in the first one. Okay, so let's just have a look at how it works. So, for any triangle, this also works in right angle triangles, but we're going to stick to non-right angle triangles. If you divide this length here, so the length of this side here, by the sine of this angle, you will get exactly the same answer as dividing the length of this side by the sine of this angle, and that will give you exactly the same answer again as the length of this side divided by the sine of this angle here. And we normally write it in this way. Okay, so side A divided by the sine of angle A is the same as side B divided by the sine of angle B, and that's the same as side C divided by the sine of angle C. Okay, remember little a, little b, and little c are sides. In practice, we don't usually use three fractions like this. We only ever use two. Okay, so in the next few slides, we're going to look at actually finding missing lengths. Remember, we use this version, so the version that's got the sides at the top. So remember, A, B, and C, lowercase letters are the sides. If you're trying to find a side, we use the version that has got the sides on top. And while we're at it, here's the alternative version. It's exactly the same, except the fractions are reversed. And notice here, big A, big B, and big C, those are angles. And so we use this version, the one with the angles on top, to find missing angles. But today we're just going to look at missing sides. Quite straightforward. Okay, so let's have a look at how this works for a particular triangle. So in this case, we have a triangle where, notice, we have an angle of 58 degrees, and opposite that is a length of 10 centimeters. Now, this is always the way where you can tell that you're going to be using the sine rule. If you have this situation where you know an angle in one corner of the triangle and you know the length opposite of the side opposite that angle, then you will be able to use the sine rule. Okay, so the easiest way to set this up is as follows. You don't actually even need to label the sides. So the side that we're looking for, which is x, divided by the sine of the angle opposite. Well, the angle opposite is 80, so we divide by sine 80 degrees, and that will equal the other length, well, that's 10 divided by the sine of the angle opposite that one. Well, that's sine 58 degrees. So that's the sine rule. That's what the sine rule looks like in this case. Now notice we want to try and find x. So what we're going to do is we're going to multiply both sides by sine 80, which is underneath the x. We need to get rid of that. So if I multiply the left-hand side by sine 80, that's just going to give me x. If I multiply the right-hand side by sine 80, well, what happens when we do a fraction times something is the top of the fraction on the right gets multiplied by the sine 80. So it just becomes 10 sine 80, and that is divided by sine 58. Now, all you have to do now is type that into your calculator. You'll need to put a bracket on your calculator. You'll need to put your bracket round the 80 and the 58. So I've worked out the answer here. I would get your calculator out now. I'd use the fraction button on your calculator, type 10 sine 80, open and close brackets on the top, sine 58 with a bracket around the 58 on the bottom, and you should find that you get the answer on your calculator, 11.6126. Remember, write down an accurate version first before rounding it to 3 significant figures. Okay, just get your calculator out and make sure that's the answer that you get. Okay, let's try another one. So here we're trying to find side x. So we know from the sine rule that x divided by the sine of the angle opposite, well, that's sine 32, is going to equal, okay, the other side that has to go on top, 14 divided by sine 110. So multiplying now by the bottom, so that's sine 32. We know that x is going to be 14 times sine 32 divided by sine 110. Okay, again, make sure on your calculator that you put brackets around these two. You don't need to write the brackets, but you will need to type them depending on your calculator. And again, if you've typed that correctly into your calculator, you should get 7.899499, which means rounding to 3 significant figures, that the side x is 7.89 centimeters. Always look and see if it's sensible. That looks pretty sensible to me, 7.89 centimeters. Okay, another example. Here we have side x. So again, we're going to have side x divided by the angle opposite. Now be careful here. It looks as though we can't actually do this one. So x divided by, oh dear, we haven't got the angle opposite, or have we? Don't forget that the angles in a triangle add up to 180 degrees. So we've got 50 and 45. Well, that's 95 degrees. That means that this angle over here will have to be 85 degrees, which means we can now do it. So x divided by sine 85 degrees is equal to, so we've got also 6 divided by sine 50. So multiplying by sine 85, x is going to equal 6 sine 85 divided by sine 50. So type it into your calculator using the fraction button. Don't forget the equals, and you should end up with, oopsie, there we go, 7.8026 blah 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 centimeters, rounding it to 3 significant figures, 7.80 centimeters. And one last question just to make sure you've got it. Here we have x, so x divided by sine 80 is equal to 3 divided by sine 40. Okay, multiplying by sine 80, x will equal 3 sine 80 divided by sine 40. Don't cancel the 80 and the 40. Okay, so the 80 and the 40 do not stand alone. They're not multiplied by the word sine. So grab your calculator. Okay, my calculator gives me for x 4.5962, and if we round it to 3 significant figures, that will be 59. It's got a 6 after it, so think of it as 59 rounding up to 60. So that's 4.60 centimeters to 3 significant figures. Okay, you'll be doing some quite straightforward questions now. Enjoy.